Okay, so right now we're going to go over the 2014 AP Calculus BC FRQ number 2. And as you can see, this is a calculator active problem, so I am going to be using my calculator. The second thing that I noticed immediately after looking at this problem is that it is a polar problem. So immediately I'm going to take my calculator and put it into polar mode, so I don't have to worry about doing that later on. Alright, let's get to reading. So I've already underlined kind of some important things, but we'll go over it and kind of see what I underlined here. So the graphs of the polar curves r equals 3, which is my first polar curve here, I've already underlined that, and r equals 3 minus 2 sine 2 theta, it's my other polar curve that I underlined, are shown in the figure above for 0 is less than or equal to theta is less than or equal to pi. So this is my domain right here. This is very important. All my answers are only going to be within this domain. I don't have to worry about any other theta numbers that are beyond that domain. So that's important. Let's go ahead and input these two curves into our R1 and R2 just so we can go ahead and get that done, and we can do functions in our calculator without having to write down the whole equation in there. So 3 and 3 minus 2 sine theta. Alright, good. Let's see what A is asking for us to do. So A is asking, let R be the shaded region that is inside the graph of R equals 3 and inside the graph of R equals 3 minus 2 sine 2 theta. Find the area of R. So it's asking us for this area right here that's shaded in gray here. So it's inside the graphs of both curves. So let's write down what we know about finding the area of polar curves. Well, we know that the area formula for polar curves is 1/2 the integral from theta 1 to theta 2 of r of theta all squared d theta, right? And the second thing that we know about finding the area of polar region is that we have to do something that's called a polar sweep. A polar sweep. And what that entails is kind of getting a ray starting at theta equals 0, moving around through your domain, in this case all the way to theta equals pi, moving around and seeing what all area we pick up that is inside here, in this case, that is inside both graphs, right? So let's go ahead and get started on that. So I'm going to use this ruler as my ray here. So I'm going to break this up into two parts. I'm going to go from 0 to pi over 2 first, and then I'm going to go from pi over 2 to pi second. So first we'll start here at 0 and go to pi over 2. And just to clarify, the green curve is r equals 3 minus 2 sine 2 theta, and the blue curve is r equals 3, right? Okay. So now let's go ahead and start our polar sweep. So I'm going to start here at theta equals 0, and let's go until about, let's say, theta equals, I'd say that's about pi over 6. There's a rest around pi over 6, right? So let me accumulate what is it within both curves. Well, what's within both curves, my accumulator bars are only going to go until my green curve here. They're only going to pick up the area within this green curve, right? Okay, let's keep going. From pi over 6 to about pi over 3, which is like right there, I'd say. And again, the only area that my accumulator bars are picking up are within the green curve. And then all the way to pi over 2. And I can see that all of my accumulator bars are within this green curve here. And the green curve, again, is represented by my first equation, 3 minus 2 sine 2 theta. So I know that the first part of my area is only going to be coming from this first curve here. So let's plug that into a formula we know. So A equals 1/2 the integral from my theta 1, I started at 0, remember? So it's going to be 0, all the way to, and I stopped here at pi over 2. From 0 to pi over 2 of, well, I realized that all of my accumulator bars are only falling within my first equation. So this is what I'm going to plug in for my r theta here. So it's going to be of 3 minus 2 sine 2 theta, all squared, don't forget the d theta. So that's what my first part of my area is going to come from. That's from 0 to pi over 2. So now we got to go from pi over 2 to pi, right? So let's get my ruler back so I can use it as a ray. Starting at pi over 2 here. Let's take a green pen instead here. And let's move to about 2 pi over 3 here. Or rather, this is 5 pi over 6, and this is 5 pi over 6. And then keep moving on another slab so I can accumulate what's within both curves. And now finally I'm here all the way, and I can finish accumulating what's within these curves. So, as shown in this one, or as shown from pi over 2 to pi, all of my area is coming from this blue curve here. None of it is outside in this green curve. All of it's coming from my curve r equals 3, right? So, again, let's plug it into my area formula. A equals 1/2 the integral of, we're starting at pi over 2 to pi. That is covered my whole domain now, from 0 to pi. Started at 0, we ended at pi. Of my curve is r equals 3, all squared d theta, right? And then my area total is going to be these two added together, right? So these two are going to be added together to get my total area from the whole domain. So, and since this is a calculator active problem, and I've inputted both my functions in, I'm going to go ahead and use my calculator to do that. So my r1 equals 3, my r2 is 3 minus 2 sine 2 theta. So we'll start 1/2 the integral from 0 to pi over 2 of my second r, which is 3 minus 2 sine 2 theta, all squared d theta, plus 1/2 times the integral from pi over 2 to pi of my first r, all squared d theta. And that should give me my area total if I do that. And I got a final answer of 9.707. 9.707.
Alright, now let's do part B. To find the value of dx d theta at theta equals pi over 6, you'll have to change the equation from polar mode to rectangular or function. And to do that, the equations are x equals r cosine theta or y equals r sine theta. And it's asking for dx d theta, so we want to find the x coordinate. So it would be x equals 3 minus 2 sine 2 theta all times cosine theta. And since this is a calculator active problem, we could plug this equation into the y value of our calculator, then click Math 8 to find the derivative, plug in alpha f4 to get the equation, and x equals theta equals pi over 6, because that's where we're trying to find theta. And you click enter, and you would get negative 2.366. And that's the value of dx d theta at theta equals pi over 6. And that's the end of part B.
Okay, now moving on to part C. So C is asking us find the distance between the two curves changes for 0 is less than theta is less than pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. So basically what that means is it's asking me to find the rate at which the distance is changing. So whenever I think of rate, I immediately think of the derivative, right? So it's asking for the rate at which the distance is changing. So that's d distance dt with respect to theta, sorry, so not even dt, d theta, d theta, that's what I'm trying to find, right? So in order to find that, first I have to find out what distance is equal to. So it's asking me for the distance from, the distance at pi over 3, right? So say roughly, let's say about that right there would be about pi over 3, right? So that's where my function is at pi over 3, and this is where my function is at pi over 3. So the distance between the two curves is what I need to be finding here. I need to be finding this distance here, right? So in order to do that, I would find the function values at either and subtract them from one another, right? So it would be distance equals 3 minus 2 sine 2 theta because we always do top minus bottom and right minus left, right? Those are 2 rules whenever working with functions there. So 3 minus 2 sine 2 theta. That's what my distance is equal to. And now it's asking me to find the derivative of that, the rate at which it changes, at pi over 3. So I'm trying to find d theta at theta equals pi over 3, right? So I'm using my calculator, and I can find these in my calculator. So what I'm going to do is I'm going to find math 8 d theta of, and since I have these saved in my calculator as R1 and R2, R1 minus R2 d theta at, it's going to be at pi over 3, right? Then I'm going to go in, and then my answer I'm going to get is negative 1.999. And that is what I'm going to get as my final answer for part C. There we go.
For part D, we're trying to find dr dt, which could also be stated as dr d theta times d theta dt. And that is dr dt. So we are given d theta dt, which is 3. So all we're trying to find is dr d theta times 3. And dr d theta can be found on the calculator if we have the equation. We have the equation typed in here on the calculator. So we would do math 8 and find the derivative of that. And I have it as alpha. I have it in as R2, but it could be whatever you put in. And we would put it as theta equals pi over 6. So we're finding the derivative of r at theta equals pi over 6. And that equals approximately negative 2. So dr dt equals negative 2. And don't forget to multiply it by 3, which is d theta dt, equals negative 6. And that's the answer for part B.